Okay, in this video, we're going to expand on our missile mono behavior so that the missiles actually target one of our cities and hit the cities through collision detection and actually give our cities some damage. The first thing I'm going to do is I'm going to go ahead and create our cityscape. So we'll have our buildings and our we'll have more buildings.
Yeah, more cities to blow up.
Right, and that's always fun. So to do that very efficiently, what I'm going to do is I'm going to select building 1 and building 2, and I'm going to hit Control D. Now Control D will duplicate these game objects. So now I can move them into another location. And I have the game window and the scene window open at the same time, so I can modify the scene while I see how it'll look when I start the game. So I'm just going to eyeball that just a little bit. Okay, so now we have more cities, or more buildings.
Yeah.
Cities, buildings.
Whatever. We'll run with it.
Yeah. So what I'm going to do now is before I actually go into the missile script and build it, I want to build another script. And that script's going to be called targetable. Now the targetable script is going to be attached to all the things that missiles can target. One of the characteristics of a targetable script is that every targetable script will have a progress bar that represents its health. So that when the targetable script gets hit, it'll know how to reduce its health and destroy the game object when its health reaches 0. So I'm going to go into code. So I'm going to select the code folder and I'm going to create a new C# script called targetable. And hit enter. Then I'm going to jump back into Visual Studio. As you see, Unity regenerated our CS proj for us, so I'm going to hit reload all. And then that is about it. I'm going to jump into targetable, and I'm going to write out some code. The code I'm going to write is pretty straightforward. I'm going to delete all this existing code. I'm going to add a public progress bar, health. Now what's interesting about this is if you recall, progress bar is a mono behavior. By adding a public progress bar field onto our targetable component, we'll be able to associate our progress bar to our targetable. Then I'm going to create a public void take damage method that takes in damage. And the damage is represented as a float. What I'm going to do is I'm going to say health.value minus equals damage. Now, if you recall, the value of the progress bar property will appropriately modify the scale of the foreground plane so that our progress bar gives us visual feedback as to how much health it has left. So I'm going to jump back into targetable. After I do that, I'm simply going to say, if health.value is greater than 0, return. That's because there's nothing else for us to do. If we still have health, we're just going to bail out of the method and not execute any more code. But if health.value is smaller or equal to 0, we want to destroy our cells. So I'm going to give you a little quiz, and I'm going to ask you what this bit of code does here. Steve?
Well, if your previous bit of code said, hey, if you've got health, no problem, let's get out, then I presume that you're about to create code that says, hey, if we're out of health, destroy the building. Right.
And you see the code I have highlighted right here, destroy this?
Yeah.
What do you think that'll do?
I think that will make the building go away.
You're wrong.
Oh.
but you said exactly what a lot of people assume. And this is a mistake I make all of the time with Unity. And something that I really want to make a very, very big point about. Destroy is a method that takes in an object. So it takes in anything in Unity. It takes in components and mesh filters and objects and everything. But this, the variable this, if you recall from how C# works, refers to the current object in C#. What is the current object in C# that we're looking at in the context of this method? So what does this here point to?
So when it hits it, it's going to make the missile go away.
No.
Oh.
It's going to make the targetable component go away. It's not going to make the actual game object disappear. It's going to remove this one component from it.
Silly artist person I am.
No, I make this mistake all the time. I say destroy this and think, oh, it'll make the game object go away. No, it won't. It'll just remove the targetable component from the game object, which isn't what we want. We want the entire game object. We want the mesh, we want the colliders, we want all of the components to go away. So instead of doing destroy this, we do destroy game object. Now, game object is a property that all mono behaviors have that points to the current game object that this component is attached to. So by doing destroy game object, we're destroying the actual game object and all of the components, not just this one component.
That makes sense now.
Okay, so now that we've done that, the take damage method isn't actually being invoked anywhere. Like, it doesn't actually really do anything. It's just a method that kind of exists on the targetable. We'll get back to using it once we flesh out our basic missile implementation. So speaking of our basic missile implementation, what we need to do is when the missile is launched, we need to pick a random object in our scene that has the targetable component on top of it. Let's go ahead and actually configure our targetable component first, so we don't have to worry about that later down the road. To configure it, all I need to do is add the targetable component to my Building 1 and Building 2 prefabs. So I'm going to click on Building 1, and I'm going to click and drag on targetable and place it on this. But there's one thing that I'm actually missing. The thing that I'm missing is that I'm not actually referencing this missile's health bar yet. So what I'm going to do is I'm going to expand this in the hierarchy, and I'm going to click and drag on this progress bar and drag it over into health bar. That means that the health bar is the progress bar that appears on top of this prefab. So in doing things this way allows us to create really complex relationships between all the components in our game.
Gotcha.
All right, so now that I've done that, what's the next step? See, I modified a prefab instance.
Are you going to have to apply that so it goes to all the other ones?
Right. So I'm going to hit apply, but I'm not done yet. The reason I'm not done yet is Building 1 is actually a different prefab than Building 2. So as you notice, when I hit apply, all of the Building 1s got a targetable, but the Building 2s did not. So I have to repeat the same process. I'm going to click and drag on targetable, put it on Building 2. I'm then going to expand this specific Building 2, move the progress bar on top of it, and drop it. Then I'm going to hit apply. And now all of our Building 1s and our Building 2s have the targetable script associated with it. You'll also notice that they all have the appropriate progress bar attached to them. So the one that's underneath them, not any other one. That's just some Unity magic that it does to make our lives a whole lot easier. Okay, so now I've basically tagged all these game objects as being targetable, but I actually have to go back into my basic missile script to select one of them to be the one that we're hitting. What I'm going to do with that is I'm going to create two private fields. Now, the first private field is going to be targetable. The second private field is going to be a vector 3 called target vector. Or how about target position? Or how about target vector?
I like target vector.
Okay, we'll go with target vector. Now, I'm keeping these two private fields. The reason I'm referencing a targetable and a target vector is that a missile could, in theory, blow up a targetable that is being referenced by other missiles that are also in the level.
Oh, so if you don't have that, then that next missile is going to error when that disappears.
Yes, it's going to just freak out because it no longer knows how to get closer to this. That's why I store where or what direction the missile needs to go to in a different variable. So I use the direction that needs to go in a different variable than the targetable, and then I can check to see later down the road if this targetable still existed when I hit something. If it didn't, that means it was blown up before it hit anything.
But that way it'll keep going at its target and just check later to see if it did any damage to anything instead of freaking out.
Yeah. Yep, it would cause an error if I tried to access this after it got destroyed. The next thing I'm going to do is I'm going to give our missile some public properties, some public fields. I'm going to give it a public float of speed and a public float of damage. The speed is going to be how quickly the missile moves, and the damage is going to be how much damage it does to the targetable when it hits it. So now I have my data all set up. I now need to write some functionality. Functionality I'm going to write is going to be first in the public void start method, which is a magic method invoked by Unity magically. when the game object comes into existence. Now the start method is going to pick a random targetable. So let's see how we can query Unity to get every single object in the scene that has the targetable component attached to it. It's actually pretty easy to do. I'm going to say possible targets equals find objects of type. Now, if you do find object of type, instead you'll get an error down the road because this just returns one object. You see that it just returns an object variable. Whereas the find objects of type returns an array of object variables.
So it's valid, so you won't see an error when you move on until you get down the line.
Until I get to a point.
Multiple things, and then it'll go, hey, that doesn't work.
Yes. So the find objects, and I emphasize this, you might be thinking it's silly for me to emphasize this, but a lot of people make this mistake of mixing up find object and not find objects, and so get component versus get components. It happens really frequently.
Well, it's not like you completely misspelled a word. If you did screw it up, it could be hard to find that if you're not aware of it. Yep.
So the find objects of type needs a type, and this is just a normal .NET reflection type class that we want to find objects of that.
Class.
That makes sense. Yeah. So I'm going to use the type of operator, and I'm going to say targetable. So this just means get me every single object in the scene that has a targetable component attached to it. Then I'm going to say if possible targets.length equals 0, then destroy game object and return. Now this shouldn't actually ever happen, but it could if in theory a missile launcher is still active after all the targetables have been destroyed. It's possible that find objects of type targetable returned an array that doesn't have any items in it. If it does that, we want to destroy the missile and exit out of the start method because there's nothing else to do. If, however, our length is greater than 0, meaning that there are more than 0 objects of type targetable, we need to find one. Now to find one, it's actually pretty straightforward. I'm going to say var target equals cast to targetable possible targets at random.range 0 possible targets.length. So what this means, let's work on this. Let's work on this code inside out in the order of operator precedence. We first start with an invocation to random.range between the values 0 and the length of the possible targets. We then take that number and use it to index our possible targets array to that index, so we get the item that is represented at that number, and then we cast it into a targetable. The reason why we have to cast it into a targetable is because possible targets are an object array, not a targetable array. So once we've done that, we can now say target equals target. Notice how I'm setting my field to the local variable. The difference being that the field is prefixed with an underscore and the local variable is not. Then I'm going to create my vector. Now my vector is actually very easy to calculate. Basically the vector is going to be what direction my missile has to move based off of where it starts versus where the targetable exists. And that's very easy to calculate with two mathematical operations on vectors. The first one is target.transform.position minus transform.position. So the first operation is vector subtraction, where I subtract our target's position from our position. That'll give us a vector that represents the direction we have to go in. However, I want to normalize this. So I'm going to say target vector.normalize. The reason I'm doing that is normalize will turn our direction vector into a vector that has each one of its components between 0 and 1. The reason I like doing that is because then it allows me to multiply by my speed, and the speed of every single missile will be the same. Finally, I'm going to say transform.lookAt target.transform. The lookAt method on the transform of our missile will position the missile so that it is looking at the direction of our target.transform. So it's just a visual thing to change the rotation of our current transform.
Yeah, so if the missile has to go 30 degrees east to the left, then it's going to turn the missile that way, so it's pointed at its target.
Right. Okay. Now, the last thing I need to do for now is I need to implement the update method. Now, the update method is simply going to move my missile in the direction that we calculated with the target vector. To do that, I simply have to do transform.position plus equals target vector multiplied by time.delta time multiplied by speed. Now, you'll notice that I'm multiplying a vector by two scalars. The two scalars being time.delta time and speed, but the result of this operation will be a vector, because a vector multiplication, in this case, will multiply each one of the vector's components by the result of this operation. Now, the reason I need time.delta time, again, is to constrain the frame rate, because our update method only gets invoked once per frame, but if we're at a 30 frames per second, it'll be invoked fewer times than if we were at 60 frames per second. So we need to put that inside of our calculation to know how quickly our update method is being invoked. Then the speed, the higher the speed, the faster our missile will go, in the direction of our target vector. So it's some really basic math that we can use to move our missile towards a target. Okay, so I'm going to jump back into Unity. The first thing I'm going to do actually is I'm going to move my launchers like up because they're really didn't want that to happen. They're really close to my my cities. I think that's high enough.
We want a little time to shoot them.
Yep. And then I want to hit play, and let's go ahead and see what happens in our scene view.
Did we not give them a speed?
No, we didn't give them a speed. That's kind of funny though.
Yeah, that's pretty. It's like a pretty missile rose.
Okay, let's go ahead and give our basic missile speed. I'm going to go over to my basic missile prefab in my project window. I'm going to give it a speed of 5 and a damage of 5. And then I'm going to hit run. And let's go ahead and see what happens. Okay, so as we see, our missiles are indeed being launched, but they are kind of sideways.
When we told it to point at it, did we not tell it how to determine what the nose of the missile was?
I think what happened is that I'm going to go into my scratch scene and delete this basic missile because we modified it. I'm going to bring this basic missile in, and I'm going to go ahead and set the rotation of my missile 1 to, let's try negative 90 on that. Or no, let's put that in 0. Now our capsule collider is incorrect, unfortunately. Let's worry about our capsule collider here in a moment. I just want to see if this will give us the behavior that we're looking for. So unfortunately, I mean, there is a way to calculate it's just like throwing them.
Something's gone awry.
Indeed. Okay, so what we need to do is we need to figure out the axis that we need to rotate our missiles, our missile in. So let's zero out Z. Let's go ahead and think about this in logic. I think actually what we need to do here is, oops, not that. I think the problem was, well,
fixture scale.
Whoops. Let's see here. If I can remember, which direction are we looking at here? We're looking at X and Y. We're looking at X and Y. We need this to actually be pointed in this direction for our missiles to be oriented correctly. And we can verify that by hitting play. And, oh, you know what's happening, actually?
Tell me. I don't know what's actually happening.
I think the problem is if you look at our missile launcher, it's actually not directly above. Yeah.
Oh, so it's getting confused when it tries to send them straight down, but the targets aren't straight down.
Right.
Along that axis.
It's assuming that they're straight down, but in reality they're not. So now if I go back into my scratch level, go back to my basic missile, and clear out his rotation, because his rotation should be empty, because we're not using his rotation. And then we take this guy and we rotate him like that, I believe, and then apply everything and go back to our level 1.
It's like magic.
It is like magic.
I never would have thought the word magic would be used making a game so much.
Well, yeah, I know, but that's how it is. Okay, so we have our missiles, and they'll get launched at our respective targets. But at the moment, they don't collide with our targets, nor do they collide with the ground. So the first thing I'm going to do is I'm going to go ahead and fix the capsule collider on my basic missile. If you recall, I kind of played around with the orientation of my missile a little bit. So I'm going to need to make my capsule collider fit with it. So what I'm going to do here is I'm going to set this to the z-axis, and then I'm going to take its y and move it up a little bit. Take its x, and whoops, I want to keep its x at 0, I believe. And I can verify that by going on top of my missile and saying that we need to move the x just a little bit over. And then we move our z up just a little bit. And that looks like a pretty good fit for our capsule collider. Okay, so I'm going to go ahead and go up to basic missile and hit apply, and that will apply the parameters we just set on our capsule collider. Now if we look at our building though, we'll also notice that our building itself does not have a collider associated with it at all. So we're going to need to make sure to give our buildings colliders as well before we can start working on our collision code. So I'm going to add a component, and I'm going to add another capsule collider, because capsule colliders just provide a really good approximation for this sort of stuff. And I'm going to move its y down just a little bit like that, and maybe decrease its radius by a tad. And I think that's about good.
It's important to note that these don't have to fit the meshes perfectly, just a visual approximation.
Right. Yep, it just needs to be believable. So then I'm going to go ahead and hit apply on our building 1. Now let's do our building 2. Now our building 2 I think would do good with a box collider, because it's a little bit more boxy. What do you think?
I think so. I would have went with box.
All right.
Well, I would have went with rectangle, but you're going to tell me they only have box.
Well, yeah. You'll notice that when you add a box collider, so I'm going to go ahead and delete that and show it to you guys again. When I go to add component and hit box collider, you'll notice Unity does its best to actually...
To automatically fit that.
Yep. See how it set the center and the size and everything to what we wanted it to be? So that's really cool.
Now, is that because it just has flat planes along an axis, so it's able to calculate that, where it would be hard for a capsule?
You notice that it also tried to do it on this. It just wasn't as good as I wanted it to be. It also did an approximation.
There you go.
But in this case, because this is so boxy, approximation works very well. So now I'm just going to hit apply, and we now have a collider attached to it. Okay, so if I go back to level 1, you'll notice that adding those colliders won't actually have result in anything happening when the colliders collide. And there are a few reasons for that. One of the reasons is that is that we don't actually have any code that responds to the messages that are sent to our components when two box colliders hit each other. So what I'm going to do here is we're going to talk about adding that code in, but we also don't have what's called a rigid body attached to our basic missile. In Unity, you need to have a rigid body attached to anything that you want Unity to perform collision detection on. It kind of specifies to Unity who's considered to be the thing that collides with other things. In this case, it's going to be our missiles, because our missiles will collide with all of our buildings as well as our silos. So we don't want to have our silos and our buildings have rigid bodies. Instead, we want to attach it to the thing that's going to hit everything, which is one of these missiles. So I'm going to go ahead and add component. I'm going to add rigid body. Now, an interesting thing about rigid body, however, is that by default, Unity will actually perform a bunch of not only calculations, but physics on this game object. We don't want any of Unity's built-in physics engine. We just want collision. So to do that, I'm going to uncheck use gravity, and I'm going to check is kinematic. Is kinematic means that we will control the position of this object. Unity will not override our decisions about where this is positioned based off things like gravity or collision. So kinematic gives us control of where we want this to be positioned instead of giving Unity's physics engine control of that. However, because it has a rigid body attached to it, it will now invoke special methods on our game components when it collides with things. So I'm going to add that rigid body and hit apply. Now there's one more thing I have to do with both of my cities, and that is I need to set them to be triggers. That's because I'm not using collision in the physics engine of Unity. I'm not taking advantage of things like force or gravity or anything like that. Instead, I'm doing triggers. A trigger is basically, think of it just like a method or an event that gets fired that simply means that two colliders have intersected. It doesn't give you physics information such as the force of the collision or anything like that, or where the point is or anything. Well, it does give you the point, but that's besides the point. No pun intended.
Yeah. Basically, it's a volume of space in the game that when something enters that space, it's going to tell something to happen.
Right. So we're going to check is trigger and hit apply, and we're going to do that with our other building. We'll go down to its capsule collider and say is trigger and apply.
It should be noted you've really got to be sure you're hitting apply.
Yes, if you do not, then it won't apply to your other prefabs, which will be problematic. Okay, so now I'm going to jump back into my level 1, and we now have all this properly configured except for my plane. My plane doesn't have is trigger selected, which means it won't hit the ground. So let's go ahead and add is trigger to that, and then we don't need to hit apply because this isn't a prefab. Okay, so by doing all of that, by adding the rigid body and setting the is trigger true, it's not actually going to change the behavior of our missiles when they collide with our game objects. As you see, they still go through them, as opposed to, well, blowing up, causing explosion, or causing damage.
Now, is that because we set it to kinematic instead of using Unity's physics?
That's because we haven't actually written any code that takes advantage of the messages.
Oh, okay.
So we need to actually go into our code, and on my basic missile, I'm going to do another magic Unity method, which is going to be public void on trigger enter collider trigger collider. The on trigger enter method will be invoked on the basic missile game object when it enters another collider. So what I'm going to do is I'm going to say, okay, so we hit something. I want to see if our target is null, or the thing we collided with's game object does not equal our target's game object. If either of these things are true, I want to destroy the missile and return. If we get past this if statement, that means that the thing we hit was our target, and we can now apply damage to it. How do we apply damage to it? We simply do target.takeDamage, and we pass in the damage that we specified as one of our fields. So I'm going to say damage. Then I'm going to destroy the missile. So now if I come back into Unity and hit play, we should see our buildings to start taking damage. soon.
Wait for it.
Yeah, I really need to change the... there we go. As you can see, our missiles are having difficulty hitting our taller buildings because of the pivot point issue. But the point is, at the end of the day, we have damage now being taken. I'm going to go into this building, our building 2, and I'm going to change his health bar to have a max value of 10 with the starting value of 10. And I'm going to hit apply. And this way we should see one of our building 2s get destroyed because our missiles give a damage of 5. So it just is going to take 2 missiles to destroy it.
Oh, there's half damage, yeah. And boom, he's gone.
Yep. Alrighty. So, unfortunately, the pivot point of our building 1s are becoming a little bit problematic.
So, kids, when your programmer calls up and says, I need a bunch of bottles right now, it's still important to remember to move that pivot point.
Right. I'm not going to worry about it a whole lot right now. We'll play around with the values because that's all it's going to be a matter of, is playing around with values. And we'll worry about that in a moment here in another video. But for now, what I want to go ahead and do is, well, I want to go ahead and have it, make sure we're verified that it's going to hit the ground. So let's go ahead and see what happens. Actually, I'm just going to go into all my buildings and remove and delete them. Come on. Oops, I destroyed the light.
Destroyed your light.
As we see, when the missiles hit the ground, they just disappear and they get destroyed. Okay, so that's really all there is to missiles, and mostly to missile launchers. We have them properly having their collision be detected, and they are appropriately choosing targets, and they're continuously flying down. So I think that's going to be it for missiles for now, and we'll see you guys in the next video.
Awesome.